Hello, everyone. This is Thara, an ocean fan on jellyfish is now here back in the deep sea to greet everyone. Hi, guys. Welcome back. กราบสวัสดีทุกคนด้วยนะคะยินดีต้อนรับกลับเข้าสู่ช่องของทาราด้วยนะคะทาราผู้นั้นของทะเลไม่ใช่แมงกะพรุนแต่อย่างใดได้ทำการแหวกว่ายกันมาทุกคนแล้วค่ะ Hi guys, hello yeah, welcome to the stream. Big sis Sarah, good evening to you too. Yeah, how are you? Hope you are doing well. I'm sniffing yadom right now. So today's this live stream is gonna be me. Well, it's gonna be a lot yapping a lot, but I try my best to work and research too because this is for the upcoming nerd content, which of course is gonna be in Thai language for nerd under the sea content. Nerd under the sea content is gonna be in Thai language. But due to the fact that I did not have that much of the knowledge on this topic, but I'm passionate to learn about it. Okay, I'm very fascinated and passionate to learn about this, but I have a knowledge of a very top level of the crust part of if you compare it to the earth layer, like my knowledge in this was like near the top part of the crust. So yeah, I have very little knowledge in this one, even though I'm very fascinated about it. So it's gonna be a while before I get to actually do the nerd under the sea thingy because I wanted to understand it. Yeah, I wanted to like truly understand like the background, like the ideology of it, like the whole knowledge of it in order for me to be able to teach you guys it. So yeah, I'm trying to study everything right now. So not long before that, I did bought a huge ass book. Yeah, I did bought a huge ass book from Asia Book. It's called Dinosaur and Prehistoric Life. The definitive visual guide to prehistoric animal by the book company called DK. DK, and it's a book that includes like marine prehistoric life too, so that's pretty good. And it's also did include like the knowledge about like transformation of earth and beginning of life, the origin of the earth, the transformation of life. They do go deep down into like chemistry, biology, anatomy, even location, like really got a whole bunch of like text and information in this one. So I try my best to read the damn book right now because I did not read the book yet. Okay, I did not read the book yet. I wanted to read it today. Okay, that's my plan. I'm doing well. That's good to hear. Today I tried bamboo shoot tempura. It's so delicious. Ooh, really? I never tried that before. I am looking forward to the knowledge. Yeah, I will try my best, I will try my best to do research today. So yeah, I got my notes ready, for taking notes. I got my huge ass book ready. It's so goddamn heavy. Like, I'm just gonna lift it up like around like 1 centimeter high from the table, and then I'm gonna drop it, okay? So around 1 centimeter high from the table, and I'm gonna drop it. Yeah, that's how freaking heavy this book is. How thick the book is? Wait. So just to like give you guys a visual a little bit, where's my damn ruler? My damn ruler for that. Ah! Ah! Just to give you guys the visual, the book is 24 centimeter wide, and it's 28.5 centimeter long, and it's around 3 centimeters thick. Yeah, so that's how huge the book is. Yeah, 3 centimeters thick, 24 centimeters wide and 28.5 centimeter long. Yeah. Yeah, so that's how big the book is. And I'm gonna try. So, before I read the book, I did watch a little bit of documentaries and videos beforehand, but I still have a lot to go through. I still have a lot to go through because some of these videos that I watch are mostly based on specific animal evolution or specific type of classification of animal in specific prehistoric era. So I still only got the base surface level of the knowledge in terms of paleontology. So I still need more information to learn, So that's why I do plan to watch more videos though nonetheless. So no worry guys. I do plan to watch some more videos because I think watching videos also very helpful to me. But I did got the book, I got huge ass book that I haven't read yet. So I plan to read it today. Yeah. Hello, good evening, Oshafe. Good evening to you too. Prehistoric time is interesting. I know, right? Yeah. Hello, Wano. Welcome to you too. Tiny small sister, yeah. Evening to you too. Big brother, Wano. Good evening. Good evening, everyone. Yeah, this book surely contains a lot of knowledge. Yeah, it's pretty good. It's contains visual. It contains a lot of text. It's pretty easy to go through it because considering they literally align the information of the books based on chronologically, from they exploring the earth past, there's origin of the earth, and then first 500 million years ago, what's happened, formation of the ocean, it's pretty cool. Plate tectonics, which I already teach you guys in the V2 Space episode of Nerd Under the Sea. Be sure to go check that out. Yeah, because I already teach that on Earth Science. I already teach on Earth Science, so I'm not gonna go through that one. Yeah, changing climate, I think I already did that. Yeah, greenhouse gases and atmosphere, okay. Life and evolution, here we go. That is the one. Evolution. Yeah, this is the one that I really need to get through it. Even though I did have some base knowledge about it, but I still need to reread some of these so I really get the facts out, the true facts out. Because I might be misunderstand a lot of concept and stuff like that. There's a lot of word. There's a lot of words in science that sometimes I can get confused with. So I need to remember all the vocabulary on this, especially since I'm gonna teach in Thai. So I need to find the real translation and also get the English version out of it too. Yeah. This is gonna be I'm gonna say this might be the most challenging topics for me, of all time among the Nerd Under the Sea episode. This might be the most challenging one ever, cause I don't want to fuck up. I don't want to fuck up. There's a lot of knowledge and information that I need to go through it, and I need to think how should I approach the topic within 2 hour each, within 2 hours time period. So yeah, I really need to think about how will I proceed through the live stream too. How do I arrange the presentation itself too. What kind of topic I'm gonna add it in, what topic can I cut it out, because there's a whole tons of pages, to go through, and it's a lot. I wonder if a lot of creatures don't turn into fossil because they don't have bones. Correct. Yeah, correct. Especially those animals with soft tissue, those are kind of hard to preserve in the fossilized form. For example, soft tissue inner organs, fur, hair, something that's soft and squishy like skin. It's quite hard to preserve, So, for example, orthoceras, if you already see the latest live stream of Dave the Diver, you will see the orthoceras. Orthoceras, for example, or orthocone, is kind of like a squid-like with a armor cone head, right? So when the scientists discovered the fossil of the orthoceras, they actually only discovered the cone part. They did not found the body part. The body part of the orthocones is actually just, prediction of how it actually looks like based just from the cone. Because the squishy part of the cephalopods or mollusks are pretty hard to preserve in the fossil. So it's pretty rare to see the body of the orthoceras. You just only found the cone part. Or even the ammonite, the ammonite, you only found the shell part of it in the fossil. So yeah, quite hard to preserve it. Only exception are if they got mummified, for example. The only way to really preserve those squishy tissue are either if they are mummified or they got stuck in an amber, for example. Because amber or those mummification method are the method that can truly preserve the form of that specimen truly well, and it's actually preserved, for example, the mummified version of trilobites, if I remember correctly. I just watched the video and they actually mentioned about this one, which actually reveal how the digestive system works, something like that. And also there's amber version of the dinosaur where they actually discover how the dinosaur actually have fur, because due to the amber version of the fossil that they found. Yeah. We have multiple EP though, right? I'm not sure about that. I need to check first on how should I approach this. Not gonna lie, because if we're gonna go through different periods, it's already a lot of things to talk about, in terms of different periods. And I'm not sure how to approach if we're gonna talk just period by period, what are the topics that I can talk about in that period, Well, first, we can talk about the evolution life form, what's going on in that period. It's fine. We can talk about example of the life form in that part. But then, if we talk about the life form in that part, we can go dig deeper down into how they actually evolution, how the evolution work on that life form, or we could just gonna focus on the geological aspect of the period itself, how the environment change and how it affect the evolution as a whole. Or we just can dig into specific type of creature or something like that, and then we can talk about that and how it's actually transformed and how it's actually doing its thing, so it's a lot. Yeah. Why put everything in circle of 2 hours? I want to limit it to 2 hours so it doesn't. I'm not sure, because I'm not sure if it's gonna be long one or just a short ass summarized one. Not sure about that yet. I'm gonna crash out. I usually sit under air conditioner and the water is raining on my back. Oh no, get yourself out of that. Get yourself out of that, Wano. I really want to see mushroom fossil. I want to imagine that prehistoric mushroom is delicious or not. Interesting. Yeah. Interesting. It's actually interesting, I actually quite fascinated about the mycelium part too, all the mushroom and fungus thing, but I'm not gonna like dig deep on that yet because all the mushroom books are with my sister right now. Yeah, all like the fungus and things like that are all with my sister. And in terms of like, science about like fungi evolution, I don't know about that much. I only know about like which mushroom are edible or not. And which mushroom is delicious. I only know about that. Amber is the best thing to preserve. Yes. We can focus on one thing, like ancestor of human at the Precambrian or something like that. Here's the thing. There is no such thing as human ancestor in the terms of Precambrian. Because if we talk about like Precambrian, it's gonna be all about crustacean ancestor. It's not human yet because human come last. And in terms of like Homo sapien, it's really came like dead last. And I'm gonna focus on like the prehistoric ocean aspect about it. So the furthest evolution that I can talk about are the lizard lineage because all the mosasaur family are actually the ancestor of the lizards. Yeah. So I can talk about that, Yeah. Hello นามายุกิ Welcome to the stream สวัสดีคุณนามายุกินะครับวันนี้พูดไทยได้นะวันนี้พูดไทยได้The story needs to have the main character so we know what are we telling. Yeah, true. That's why I try to navigate like, to narrow down all the topics right now. So I want to read some of like the books because all the videos that I watch right now are mainly like focused on like specific creatures. Something like that. The video that I really love to watch are like the evolution of the squids and krakens and octopus. So I truly know about that. That's why I can classify like ammonites and orthocon and something like that and orthoceras and things like that. Because I love to watch those videos. But yeah. We can just like mainly focus on like the creatures in certain period if you guys want to, but I also want to dig down a little bit on like the evolution part on why it's actually thriving and how those creatures are thriving in this period and they just like poof, snap, gone. Yeah. This is my favorite spot. Oh no, I will write Uncle Crocodile to your sister to get books. A specific creature can be focused. Yeah, true. But then in terms of like Precambrian period, we can there's like only like a few creatures that we can talk about, because like all the creatures in that period are all like sponges and corals and seaweed, They're like only like the most basic ass form of animal, and then when it comes to Cambrian period, that's when we got like Anomeracaris, something like that, the trilobites, something like that, all the ancestor of the crustacean, the sea scorpion, something like that. Yeah, we can talk about that too. Day in the life of this overworld. Yeah, rise and fall of the overworld. Yeah. Because like we need to like dig in on how some of the certain species can survive the great extinction. Yeah, the great extinction. Because like at the end of each period, there is a great extinction that wipe out like 80% of the life form on Earth. So when it's end of Cambrian period, 80% of life form wipe out. End of Ordovician period, 80% of the life form wipe out. So I want to kind of like touch on that, how like some of the certain creature actually survive it and live so long life, and actually evolve into like animals that we see today. For example, like jellyfish or horseshoe crabs. Corals are the mysterious animal that I want to understand. Ooh, interesting. I will try my best to find that, okay? I will try my best to find that one. Y'all ever heard of the joke about how evolution keep turning things into crap? Yes! I do! You know, there's thing called false crab. So, for example, hermit crab are considered false crab. Coconut crab is false crab. The pom-pom crab is actually a false crab. So a lot of crabs are not real crabs. You know, like spider crabs. You know, like the snow, the giant snow king crab. That one is not a true crab, too. So, and there's a joke about like someday human gonna turn into like a crab. This one is actually false, at least for now. Because like most of the thing that can evolve into like a false crab, into like a crab shape like thing, are mostly in like the crustaceans. Yeah, mostly are in the crustacean family. So the rest of the thing will probably not evolve, kinda. But yeah, I actually do get to research on that a little bit, so I it's pretty fascinating. And also like there's some like question on like why crabs, or like why not lobster, and they actually like explain like because of like the anatomy, like the body shape of like the crab, that is actually the most perfect form in terms of like adaptation and in terms of like evolution and things like that, you know. So it's pretty fascinating. Imagine one day you wake up and you have 2 big fingers with 8 legs. Yeah. The Great Extinction are different too. I watched a clip about extinction by plants today, and my curiosity is just peaked. Ooh, so most crabs today are not crabs, right? There are 2 classifications, you know. There are crabs that are actually true crabs too, and then there are false crab. A lot of them are false crab though. Let me see if I can pull up the picture for you to spot the difference, you know. False crab. So yeah, so the false crab are actually called anomura. And the prime example of the false crab is the coconut crab, the yeti crab, the giant spider crab, and the hermit crab. So let's see if I can see like the good picture. Yeah, so the true crab are called bracula. Bacular, and the false crab are called anomura. Okay, let me save the picture a little bit. Like, there are some of the pictures that we need to hit on about this, because they're actually like the different. We can differentiate them quite a lot. You know, let's see. Like, where the hell is that picture? Okay. Yeah, this one is pretty good. There are some like, I can zoom this one later. So let's see. Let me do. Here. So there are 2 types of the crabs. So there are 2 crabs, you know. Bracula are the true crabs. Anomura are the false crab. Judging from its appearance, you can already kind of like see the differentiation of like the anatomy itself a little bit already. You know, in terms of like shapes and the leg itself, and how the claw are shaped, and also the body shape too. How the body shape and how they walk can also be differentiated from the true crabs, you know. And also, I found the better picture, which is this one. They are seafood, yeah. Spicy seafood crabs are delicious. Speaking of these stuff, I find the idea of pistol shrimp is very interesting. Yeah. My favorite are ปลาเผาเกลือ and กุ้งเผาOh, I understand now. Okay, this one is pretty good one, you know. So let me zoom the damn thing right now. Here's our like how to differentiate. You know, the hermit crab, the king crab, you know, these are false crab. In terms of like their anatomy, you know, the circle shape versus like the round edge, the oval edge shape, and how these guys are walk sideways. These guys can walk, you know, front and back. So it's already not the same. Also, evolutionary group Bacteria and Anomura. Tail structure, short flattened abdomen, and the abdomen tucked tightly under the body. Compared to the tail structure of the Anomura, abdomen longer, often asymmetrical or partially exposed. Body shape, broad, compact body and wider than long. Body shape, often longer body or uneven. Example, for the true crab are blue crab, Dungeness crab, green crab. Example for the false crab is hermit crab, king crab, porcelain crab. Edibility, most of the commercially edible crab species are true crabs. And the edibility for the false crab, some are edible like king crab and many of the false crab are not targeted. For example, hermit crab, we do not eat that. Also, leg count and function. 10 legs, all visible and functional. For leg count on the false crab are 10 legs, but the last pair is often reduced or hidden. So there's a difference, you know. Also, thank you for the World Wide Wildlife. What is that? WildlifeNomad.com. Thank you for that picture. Yeah, kudos W to Wildlife Nomad for educating us about the true crabs and false crab. That's pretty fascinating though, no? Yeah. Oh my delicious crustacean. Hello MT. Welcome to the stream. สวัสดีนะคะ Well, these are different. Are the differences? Yeah. Thank you, Vixis. You're welcome. Yeah, I'm pretty fascinated about that one too, to be honest. Not gonna lie. Okay, so let me go back to my reading a little bit. Thank you. Let's see, what should I cover on and take a little bit of notes on these books. You know, even though I said that this stream is gonna be working stream, but mainly I'm gonna yap, to be honest. I wanna yap with you guys, you know, about like all like the knowledge and stuff like that. While I do some a little bit of research, you know, it's gonna take some time to actually do this topic, like cover this topic in Nerd Under the Sea. Also, spoiler alert, I got a logo for Nerd Under the Sea. So stay tuned for that. I already have logo for the show. Lurking as usual. Okay, no problem na, empty. Low-key want the power of pistol shrimp though. I'll be ultimate superhero. Oh yeah, how it actually snapped, like the snap was so powerful that it's create like a light shock. Like a shock. So that's why it's called pistol shrimp. That's pretty cool. Research about Mr. Crab? No, it's about prehistoric ocean. But I wanna cover things like evolutionary life form in the sea specifically. So yeah, I try my best to read a book right now. คือตอนนี้กำลังอ่านหนังสืออยู่ค่ะเป็นหนังสือเล่มที่มีชื่อว่า Dinosaur and Prehistoric Life นะคะ The Definitive Visual Guide to Prehistoric Animal นะซื้อมาจากเอเชียบุ๊กครับผมเป็นหนังสือที่ใหญ่โพดนะก็คือกำลังหาอยู่แล้วก็กำลังนั่งดูอยู่ว่าจะเอาเนื้อหาอะไรไปใส่ใน Nerd Under the Sea ดีแต่ว่าอันที่จะโฟกัสก็คือตรงPaleozoic Era นะครับผมก็คือจะ cover Precambrian Cambrian Ordovician Devonian อะไรอีกวะ ลืมชื่อ ขออนุญาตย้อนกลับไปดูสารบัญ Silurian ใช่ Silurian ด้วยนะครับผมแต่ก็คิดอยู่ว่า นอกจาก Paleozoic era เนี่ยก็อาจจะไป cover พวกสัตว์ทะเลที่อยู่ในยุคแบบหลังๆนี้ด้วยอย่างเช่นพวกCarboniferous Permian Triassic Jurassic Cretaceous อะไรอย่างนี้เนอะเพราะว่ามันก็จะมีแบบพวกสิ่งมีชีวิตใต้ทะเลเหมือนกันที่เปลี่ยนไปเนอะที่เข้ามาใหม่ในยุคสมัยต่างๆนะถึงแม้ว่า Paleozoic era มันจะเป็น era สำหรับในทะเลโดยเฉพาะเลยก็ตามนะแต่ว่า even though like Paleozoic era are mainly the era of life form in the sea there's no like animals on land yet before Paleozoic era so it's pretty fascinating if we gonna focus on Paleozoic era but the thing is a lot of cool creatures are from a lot of cool creatures under the sea are actually from like the later era like Permian Triassic Jurassic a lot of like aquatic creatures are pretty cool in this era too so I'm not sure how much I can cover but I'm gonna focus on the oceanic creature like oceanic part nonetheless I'm not gonna focus on like on creature on land or anything like that it's not my jam ก็ทาราต้องพูดเลยว่าทาราจะไม่ได้ cover ในส่วนของยุคหรือสิ่งมีชีวิตหรือการเปลี่ยนแปลงอะไรบนบกสักเท่าไหร่เพราะว่าถ้าพูดตามตรงคือทาราไม่ได้ fascinate เกี่ยวกับไดโนเสาร์ออนแลนด์ขนาดนั้นทารา fascinate เกี่ยวกับสิ่งมีชีวิตใต้ทะเลที่เป็นยุคโบราณมากกว่าต้องพูดอย่างนี้เลยสวัสดีคุณดรีมด้วยนะคะสวัสดีค่ะปารากีบูดปายาบาฮูพารากีบูดเหรอแป๊บนึงขออนุญาตเช็คโอ้โหไม่กล้าพูดเลยว่ะ1295แต่ตอนนั้นหม่อมพ่อมีส่วนลดตอนนั้นหม่อมพ่อมีส่วนลดก็เลยจ่ายน้อยกว่าราคาเท่านี้พาราเท่านี้Loki if the Tiktaalik still exists I'll try to keep one as a pet Cenozoic era มีสนใจไหม Cenozoic มันไม่มีในหนังสือเนี่ย What the fuck is Cenozoic era wait nope not really มันเป็นพวก Ice Age ใช่ไหมพวกนี้จะไม่ค่อยสนครับผมจะไปสนแบบพวกใต้ทะเลมากกว่าทาราจะชอบใต้ทะเลมากกว่าครับทาราจะไม่ค่อยสนแบบพวกออนแลนด์สักเท่าไหร่เพราะว่าไอ้พวกแบบบนบกอะไรอย่างเงี้ยมันมีสอนมันมีข้อมูลสอนไปเยอะแล้วบอกว่าทาราไม่ได้ fascinate อะไรเท่าไหร่ขนาดนั้นคือแบบเข้าใจเพราะว่าสิ่งมีชีวิตออนแลนด์มันถูก study เยอะกว่าพวกใต้ทะเลแล้วทารารู้สึกว่ามันน่าสนมากกว่าพวกใต้ทะเลสำหรับทารานะเพราะว่ามันนั่นแหละมันดู mysterious แล้วมันดู demonic มันดู monstrous มากกว่าคือlike I'm gonna say this like the creature under the sea especially like prehistoric creatures are truly looking terrifying and kind of monstrous compared to like the creatures on land to be honest they are more terrifying than like creatures on land to be honest like for example like mosasaur Dunkirostrius totally monsters the Ottoceras the ammonite what else the sea scorpion the Anomera caries they look like monsters they're much like fascinating and interesting ไม่ได้ถามเลยว่าแชทแม่มราคา แต่ตอนนั้นหม่อมพ่อผมมีส่วนลดไงก็เลยลดไปเยอะพอควรอยู่Art bachelor with a mind of marine biologist yeah yeah bachelor in such a language but the mind of marine biologist yeah that's me ผมจำชื่อไม่ได้แต่มีหมึกตัวหนึ่งในยุคคริเทเชียสมันกินโมซาได้ตัวยาว18เมตรตัวนั้นคือบรรพบุรุษที่สามารถเรียกได้ว่าเป็นแครกเคนเลยมันชื่อว่าเดี๋ยวนะ prehistoric อันเนี้ย ทำไมกูจำชื่อไม่ได้วะทั้งที่ฉันก็เพิ่งดูวิดีโอมาไม่นานมานี้เองคือปัญหาหนึ่งเลยนะปัญหาหนึ่งเลยที่ทำให้ทาราไม่มาสอนเนื้อหาพวกนี้ทีอะสักทีอะเพราะอะไรรู้ปะกูจำพวกชื่อไม่ได้ คือจำชื่อไม่ได้คือแบบดูมาแล้วจำหน้าตาได้แต่จำชื่อไม่ได้ กูจำชื่อไม่ได้what the fuck แต่ว่าต้องบอกก่อนเลยนะว่าไอ้ปลาหมึกพวกเนี้ยมันเป็นบรรพบุรุษของคือหน้าตามันเหมือนปลาหมึกที่เป็นแบบพวกจำแนกแบบสควิดมากกว่านะแต่ว่ามันเป็นบรรพบุรุษของพวกจำแนกออกโทปัสเว้ยซึ่งแบบเฮ้ยฟาสเนตติ้งอะทั้งที่หน้าตามันเหมือนสควิดนะแต่มันเป็นบรรพบุรุษของพวกออกโทปัสเว้ยแบบเจ๋งดีว่ะปลาหมึกที่ล่าโมซาซอใช่ไม่ใช่ออโตคอนพวกนี้เป็นยาวแค่ประมาณ 2-3 เมตรมันจะเป็นตัวไทราซามันชื่อว่าอะไรวะTriassic Kraken มันจะมีปลาหมึกในยุค Triassic อะที่มันจะกินพวกแบบตัวบรรพบุรุษที่เป็นไดโนเสาร์พวกโมซาซอร์เนี่ยแหละตัวตมาเตะมันมีแต่พวกออโตโคนโผล่มากับพวกthis thing what is this dude called the Nanaimotutus Cretaceous Kraken it's called Nanaimotutus god damn it the name is so goddamn it Nanaimotutus yeah that's the name มันเป็นจะเรียกว่าเป็นปลาหมึกเป็นหมึกยักษ์ที่ใหญ่ที่สุดเท่าที่เคยเรคคอร์ดมาบนโลกนี้เลยซึ่งต้องบอกก่อนว่าไอ้พวกหน้าตาพวกเนี้ยหน้าตาที่เขาโผล่มากันหรือว่า predict กันเนี่ยมันไม่ได้มีในฟอสซิลเว้ยแต่ว่าถามว่าเขาpredict ได้ไงว่ามันเป็นหมึกที่ใหญ่ที่สุดในโลกเท่าที่เคย exist มาบนโลกเนี้ยคือมันมาจากการที่เขาเจอกระดูกปากเขาดูจากกระดูกปากของเจ้าตัวหมึกนี้เลยแล้วมันเป็นกระดูกปากที่ใหญ่มากๆแล้วการเปรียบเทียบคือต้องเทียบกระดูกปากกับ body mass โดยเอาหมึกสายพันธุ์ปัจจุบันเนี่ยมาเทียบไซส์กันซึ่งมันเลยสามารถ predict ได้ว่าไอ้หมึกตัวเนี้ยมันมีขนาดที่แบบว่าใหญ่มากๆแล้วใหญ่กว่าหมึกยักษ์ในปัจจุบันอีกเนอะgiant squid เนี่ยมันอยู่giant squid ในปัจจุบันเนี่ยมันอยู่ที่ประมาณ12 เมตรเนอะแต่ว่าไอ้ตัว fin octopus หรือ Nanaimotutus เนี่ยมันอยู่ที่ประมาณ19 เมตรถือว่าใหญ่มากแล้ว Mosasaurus อยู่ที่17 เมตรนะครับผมเรียกว่าค่อนข้างโหดและใหญ่ถือว่า define ว่าเป็น Kraken ในยุคสมัยโบราณก็ว่าได้เลยเนาะอันนี้อยู่ในยุค Cretaceous เนาะชื่ออ่านยากมากจริง Octopus but look like a squid where's the seafood you know like I can go yap like on and on about like how actually like this giant squid evolution are so fascinating I love to learn about like giant squid like and also the colossal squid evolution because the colossal squid and the giant squid are actually not the same species of squid even though they are gigantic but they are not the same you know the colossal squid like the humble I think wait not the humble wait there's a giant squid and colossal squid wait so I thought that colossal squid are the same as giant squid but apparently it's not because of the body mass yeah it's a colossal squid because compared to the giant squid is longer but the body mass is lower compared to the colossal squid is shorter but the body mass is bigger and they live in like the different region of the ocean, so they actually never met each other. It's pretty cool, and it's crazy how to that like you see like this gigantic red colossal squid, right? But they are actually the lineage from glass squid. Those like teeny tiny squid that are like transparent looking, they are freaking from the same lineage. Like that's crazy, man. That's crazy. Okay, I can yap about this like for a long time. Anyway, the same looks like Aztec gods. I know, right? Hello, Nongkiwa. Welcome. Hello, Sis Thara. For now, all I can do is say hello. I'm currently on the bus heading back to Bangkok. Oh, have a safe trip. Okay, Nongkiwa. But hello. Thank you for saying hello to me too. But yeah, have a safe trip, okay? And hello, Mr. X. Long time no see. Hello, I'm new here and welcome back. Giant squid in Cretaceous, a limited grilled squid. I know. And like, it's actually very crazy how like creatures in the past are actually so freaking massive. But then compared to like, the present time where like the largest creature exists in like the present world is the blue whale, which is still smaller than like the prehistoric creatures, so that's pretty crazy. Yeah, I can yap for a long time about this. I think it's about oxygen level in the past. Correct. Yeah. Correct. And another factor why all the massive creatures couldn't survive in the sea in the present time right now is because of the food source. Because you have to remember in terms of like anatomy, like the typical like science biology anatomy thing, the bigger your body is, the more energy is used. And how do you replenish those energy? It's by consuming a lot of food in order to maintain the energy in your body. Yeah, so that's mean that you have to eat like a shit ton of food if you wanna survive. And creature that massive, like for example, megalodon. Why megalodon do not exist in the present ocean anymore? Even though people still like have speculation that megalodon still exists. Right now, it's actually impossible because if we have a shark that massive, it requires shark to eat like more than 10 whales a day. And we do not have enough whale in the ocean to satisfy just one megalodon. So it cannot survive. The megalodon cannot survive because it do not get enough energy. It do not get enough food source. And if it actually happen to survive, the ecosystem will collapse. Literally, like the ecosystem will collapse like entirely. Because the balance in terms of like ecosystem and natures are wrong. It's already collapsing, like the whale population's gone, like the massive creatures population are gone. What happened to like the smaller fish? They are overpopulated. Ecosystem collapse. And we are cooked. We are fucked. So that's why it do not exist anymore. So this is why megalodon has no chance to survive. Correct. Correct. Yeah, so you have to remind yourself, okay? The massive prehistoric creature could not survive is because of the energy preservation factor. The bigger your body is, the larger amount of food you have to take in order to preserve the energy inside your body, or else you will die. So yeah, you got some new knowledge right there. Okay, let me. Should I talk about like a little bit of like fossil records a little bit too? I'm not sure about that. I don't know if I should talk about fossil records too, or else it's gonna be too long because I want to focus on the prehistoric ocean mainly, but like, yeah. Okay, let's read about the life and evolution part first. The only thing I want to become gigantic is cheese wheel. Lol. Oh yeah, but there's like some exception, you know. If you notice, the most of like the gigantic sea creatures, like majority of the gigantic creatures are actually either in the deep sea or in the cold region. There's the terminology called deep sea gigantism and polar gigantism. Yeah, because like this is like in terms of like evolutionary adaptation that I still haven't got to dig deeper into this, so I cannot explain that much. Why is it really that gigantic? Yeah, I still need to study more about like polar gigantism and deep sea gigantism, which is gonna be a very, very interesting topic to talk in Nerd Under the Sea too. Oh my god, new idea popping up! Hell yeah! Hell yeah! Actually, do you want to talk about ocean technology or ocean engineering or ocean cleaning process or something like that? Hell no. I do not touch on technology on that at all. I read a lot about engineering, but not the ocean one. No. In terms of engineering stuff, I do not read on that at all. I usually skip on that. Like, for example, like the submarine thing or like the commercial boats and ship thingy, my dad is actually very fascinated about it, and he actually told me some of like give me some like knowledge about it, but I only know like a little bit of snippet about it, and I am not that interested. I like gigantic jellyfish. Correct. Mainly, specifically, lion mane jellyfish. That one is polar gigantism. Yeah, lion mane jellyfish, or the largest jellyfish that exists in the present time, is actually near the Arctic part. You know, it's live in the colder region of the water. So it's actually the effect from the polar gigantism. And deep sea jellyfish, like phantom jellyfish, that one is also deep sea gigantism. The more you know. Great Big Brother Ode is tricking us to talk about technology again. It's time to write Uncle Crocodile. Yeah. Write the Uncle Crocodile. I allow you this time. Yeah, I allow you this time. Life condition. Life can be defined as condition in which organic animate matter is distinguished from inorganic animate matter by its ability to renew its complex, highly ordered structure. It includes a capacity to change, growth, and reproduction with functionality maintained until death, when its constituents disperse back into the environment. Wait, I skipped the line. Back into the environment. Oh yeah. Wait. No. Highly ordered structure. This includes capacity for change, growth, and reproduction with functionality maintained until death, which is constituents disperse back into the environment in order to maintain itself. Life must be able to get energy. Yeah, life must be able to get energy and raw materials from the environment as well as manufacture everything necessary for growth, repair, and replication. This is a main word. You know, in terms of evolution, in terms of like survival and adaptation. This is the sentence for it, you know. In order to maintain itself, life must be able to get energy and raw materials from the environment, as well as manufacture everything necessary for growth, repair, and replication. This is the main idea for the key for evolution and adaptation to the environment, you know. Well, it's interesting. Thank you, Big Sis. It is fascinating how we people working together to do something. We create submarines, create logistic transportation across the ocean, etc., etc. Human is fantastic. I know, but I want to talk about animals, you know. I want to talk about animals more than technology, you know. Low-key technology is my enemy, you know. If you guys don't know yet, low-key technology is my enemy. Just my hobby stuff. Yeah, I already know. Yeah. You are engineer freaks. The only element that is known to form a living structure is carbon, which can combine with itself and other elements, notably nitrogen, oxygen, and hydrogen, to form a molecule of a great diversity and complexity. Four main groups of organic carbon compounds are found in living organisms: carbohydrates and fats, which supply energy, protein built from amino acid, which form structural tissue, and nucleic acid, the basic component of the genes. Okay. So there's sexual reproduction, and then there's photosynthesis, there's asexual reproduction. Some organisms such as ciliate protozoan reproduce without sex. So cells, gametes, here's the protozoan use binary fission. It duplicates its DNA, then divide into two parts. Each new protozoan holds a copy of the parent's DNA. Pretty interesting in terms of like genetic and stuff. Life in the past. Numerous species of plants and animals have evolved to become extinct, preserved only as fossil. The first dinosaur evolved in the Triassic period, and the group became extinct at the end of the Cretaceous. Okay. What is evolution? Here we go. What is evolution? Evolution is a scientific theory which states that the plants and animals change genetically over time, modifying and adapting over generations in response to the demand of Earth's changing environment. This biological process includes reproduction, diversification, and adaptation. Charles Darwin, of course, is Charles Darwin, the father of evolution, who formulated this theory of natural selection in the 1837 and to 39, called the process descent with modification. The descent from a common ancestor with the modification of biological characteristics over time. Natural selection is a key evolutionary process brought about by survival of organisms best suited to their local environments, the survival of the fittest. Okay. So let's see, there are some like pictures. Arms and flippers, oh yeah. The anatomy often reveals a shared ancestry between species. For instance, a chimpanzee arm looks very different to dolphin flippers. But the sequence from the shoulder of a single humerus bone followed by a pair radius and ulna and a series of the wrist and a finger bones can be identified in both animals. Let's see. Oh yeah. So okay, chimpanzee arm. There's humerus, their radius, their ulna, their wrist bone, and there's digits. So literally the same parts, but just like in a different shape. Yeah, the anatomy of the chimpanzee arms bone and the dolphin's flipper skeleton, they all have like the same key parts, but it's just in different shape. Wait, I forgot because I remember I studied about this like during high school. What does it call? There's like a different type of evolution. Evolution types. I need to search about it. Okay, because I remember there's a name for like different thing, you know. Here we go. Divergent evolution, convergent evolution, parallel evolution, and co-evolution. There we go. Here it is. Totally forgot about this. โอ้ยลืมไปหมดแล้วอ่ะคือเคยเรียนตอนมัธยมม.ต้นจำได้เกี่ยวกับ evolution แต่ว่าจำชื่อไม่ได้แล้ว Divergent evolution. One species split into two or more different species happen with a common ancestor adapt in different new habitat. Example, Darwin flinches on the Galapagos Island. เกาะ Galapagos. Okay. Evolution thing. Wait, let me learn and understand about evolution thingy first. Four types of evolution. An example pattern of evolution. An example pattern of evolution is the rate of change that may occur as either gradualism or I can't fucking pronounce this. Catastrophism. Okay. In gradualism, evolution occurs slowly and incrementally. In catastrophism, evolutionary change occur drastically in a short period of time. Okay. To unlock this lesson, you must... Damn it. You must become a member of this website. God damn it. Why? Website? I don't want to pay. I don't want to pay for this. Okay. Divergent evolution. Okay. When people hear the word evolution, they most commonly think of divergent evolution, the evolutionary pattern which two species gradually become increasingly different. This type of evolution often occurs when closely related species diversify into new habitats. On a larger scale, divergent evolution is responsible for the creation of a current diversity of life on Earth. From the first living cell on a smaller scale, it is responsible for the evolution of humans and apes from a common primate ancestor. Okay. I get that one. Convergent evolution caused difficulty in fields of study such as comparative anatomy. Convergent evolution takes place when species of a different ancestry began to share an analogous trait because of the shared environment or other selection pressure. For example, whales and fish have some similar characteristics since both had to evolve method of moving through the same medium, water. Okay, got it. I got it. Actually, I am working with my teacher friend to list all of the ป .1 ถึงม .6 Thai standard education so they can track the progress and develop further learning course. Do you want one? Low-key interested. I'm low-key interested. Low-key interested in that too. Okay. I got that one. Okay, divergent and convergent, check. Parallel evolution occurs when two species evolve independently of each other, maintaining the same level of similarity. Parallel evolution occurs between unrelated species that do not occupy the same similar niche in a given habitat. What the fuck does that mean? Can I get parallel evolution example, please? Yoink. Occur when closely related species independently evolve similar traits of behavior, adapting to similar separate environment. Let's see. Divergent is A evolved to S, A evolved to T. Parallel is A evolved to S and A evolved to S. Convergent is A and T evolved to SS. What? That one is confusing. No, I'm not gonna get that one. Let's see. Here's some picture. Let's see. Parallel evolution of a marsupial and placental mammals. Okay. Short-headed glider, strict glider. Oh, you mean like... Wait a damn minute. Huh? You mean just like different species? What the fuck is parallel evolution? Wait, I need to reread this again. Convergent. Okay, I got that one. And I got the divergent. I got the convergent. What the fuck is parallel evolution? Parallel evolution versus convergent evolution. Okay, here we go. Parallel evolution refers to independent evolution of similar traits in different but equivalent habitats. Convergent evolution refers to the independent evolution of analogous structure in unrelated species. Occur in different but equivalent habitat. Occur within a particular habitat. Two distinct species evolve independently, maintaining the same level of similarity. Two distinct species evolve analogous trait. Occurs in an unrelated or distantly related species. Occur in the unrelated species. Example, evolution of old world monkey and a new world monkey. Development of eyes of vertebrate cephalopod and cnidarian. What the fuck? How did I get it during high school? Like during high school, I am actually a pro on the evolution thing, but now I totally forgot about every single shit on this thing. How the fuck did I get a full score on this subject? Like I literally get a full score on the evolution part of the exam. How the frick? Now I don't get it. When you said about evolution, it reminds me of that project I am working with my friend. I see. What the frick? Okay, books. Do you have that one? Okay, let me see if you dive deeper on the evolution or not. There's co-evolution. Oh, this one is like macroevolution and microevolution. Evolution through geological time. Classification. Nope. They do not mention about parallel evolution whatsoever. They only talk about co-evolution. Dang it. They also talk about genes and DNA though. And also adaptability and what drives evolution. Okay. Yeah. Hi. Hello, mommy. Hello, mommy. I gotta welcome. Hi. Now work can't stop me to be here. You have work too, right, mommy? โอ้ย mommy เดี๋ยว mommy ไปงานไหนนะลิลลี่เฟสป่ะหนูไม่แน่ใจว่าหนูจะได้ไปหรือเปล่าแต่อยากไปมากเลย อยากไปมากเลยอ่ะ ตอนนี้หนูกำลังหาข้อมูลอยู่คือตอนแรกอะอยากจะไปโฟกัสที่ Paleozoic Era นะก็คือในส่วนของมหาสมุทรในยุคโบราณแต่ว่าหนูรู้สึกว่าหนูควรจะมีข้อมูลเกี่ยวกับเรื่อง basic knowledge เกี่ยวกับเรื่อง evolution หรือการวิวัฒนาการสักหน่อยเพราะว่ามัน cover ในเรื่องคือเนื้อหาพวกนี้มันต้องพูดถึงเรื่องการวิวัฒนาการด้วยไม่งั้นทุกคนจะไม่เก็ตไงก็เลยมานั่งหาข้อมูลแล้วก็นั่งทำความเข้าใจเกี่ยวกับเรื่องการวิวัฒนาการของสิ่งมีชีวิตอยู่ครับผมแมน Yeah Lily Face and Movie Carnival หนูจะไป Movie Carnival หนูจะไปนะฮะจะไปเป็นวีเสียงMovie Carnival นะหนูไม่พลาดอยู่แล้วไม่พลาดอีตู้ What the fuck is parallel evolution? Can you guys give me some like definitive example please ผมต้องแวบกลับมาภาษาไทยเลยเอาจริงเลือกว่าสิ่งมีชีวิตก็ต้องไปฝั่งวิวัฒนาการจริงแหละค่ะก็ใช่ไหมอ่ะมีคือถ้าเกิดหนูจะไปพูดเรื่องแบบสิ่งมีชีวิตโบราณตรงๆเลยมันก็จะไม่มีเรื่องให้พูดเยอะขนาดนั้นนะเพราะฉะนั้นเราก็เลยอยาก dive deep down ไปในเชิงของ evolution สักหน่อยเพราะว่าการวิวัฒนาการอ่ะมันส่งผลว่าทำไมถึงสัตว์สิ่งมีชีวิตเนี้ยถึงไม่ได้ไปต่อหรือว่าสิ่งมีชีวิตนี้ถึงได้ไปต่อหรือว่าสิ่งมีชีวิตนี้มัน evolve ไปเป็นอะไรหรือสิ่งมีชีวิตนี้มันคือบรรพบุรุษของสิ่งมีชีวิตอะไร you know so it's like I wanna dive deep down first, you know. ทำไมจู่ๆทาราก็เสียงเบบี Why am I started to sound like a baby for some reason? When Mamiya Garu come in, my voice just literally turned into like a baby. ไม่ต้องมีเสียงต้องมีเสียง on live girl マジやばいですねI have no idea. I still don't get it. What the frick is parallel evolution? Example of parallel evolution. Here we go. When similar related species independently evolve the same trait because they face the same environmental pressure in the separate location. โอเคเก็ตแล้วเอาจริงถ้าเราฝั่งอีเวนต์ธรณีวิทยาหรือว่าทำไมถึงลักษณะนั้นในการใช้ชีวิตตอนนั้นมันก็มันเหมือนกันถ้าเรามีพูดถึงธรณีวิทยาไปแล้วนิดนึงในตอนเอพิโซดV2 Space Special ที่เป็นเกี่ยวกับ Earth Science อันนั้นถ้าเรามีพูดนิดนึงไปแล้ว Which evolution type again that border you parallel evolution so I get the convergent and divergent evolution but like the parallel evolution that one kind of like bothers me like I low-key get it or not get it so it's basically like related species evolve the same trait because they are face the same environmental but they are in different location so for example like the rainforest maybe the animals gonna adapt to the rainforest like the same species but then they are living in like the different continents maybe and then so they evolve into like a different species not like entirely different species but they still like well kind of different species but they still have like same traits of it I see the Galapagos thing really isn't that divergent wait the Galapagos thing isn't it divergent evolution I am confused man how the frick did I get a full score during high school? I totally forgot about these things. Separate plant family repeatedly develop identical leaf pattern and vein structure to manage local sunlight and water. No. Flying squirrel and gliding pelanger. Pectoral flying squirrel and marsupial sugar glider both evolve membranes to glide through the tree from separate ancestral starting point. Huh. Is it that conversion thingy? Let me use the research tool to do it. I'm not sure though. Yeah, I'm not sure either. I'm starting to be confused. I started to get confused, man. Not the study.com. I need to be a member of it to see it. Oh my god. Yeah, the divergent evolution is mainly the prime example of the divergent evolution are the Galapagos Island. Natural History Museum, help me please. Okay, convergent evolution explained with 13 examples. What is convergent evolution? Convergent evolution occurs when organisms aren't closely related, evolve similar features or behavior, often as solutions to the same problem. The process can be resolved in matching body shapes, colors, pattern, or ability. Dr. Natalie Cooper is one of our evolutionary biologists who specialize in vertebrates. Explain in convergent evolution, two organisms look or behave in a very similar way, even though they are only distantly related. That means they are independently evolved, those similarities rather than inheriting them from a common ancestor. What? Wait. They independently evolve those similarities rather than okay. We observe this phenomenon all over the tree of life. Okay, from mammals to invertebrate to plant to microorganism. Okay, maybe look like the same thing as humans and monkey. I think that one can be parallel. Yeah, I think that one is an example of parallel evolution, but I need the explanation of it, okay? I need the explanation of it. I still don't get it. Oh my god. Let's see. Natural selection. Okay. Some example of convergent. Species evolve the same solution to a problem, but take a different genetic route to get there. In other cases, the convergence takes place at the molecular level and the same genetic change occur in different species. How do we discover convergent evolution? Scientists have known for a long time that species that we assume were only distantly related had evolved to the same or similar adaptation to the same environmental pressure. The discovery of DNA helped them to confirm this theory. Natalie explained, until we understood DNA and how it evolved, there were a lot of things that we thought were very closely related because they look similar, but they turned out to be very distantly related. Okay, so I get the convergent now. I get the convergent one now. So for example, falcons and hawks and eagles look very similar birds of prey, yet we discovered that they actually really distantly related. Falcons are more closely related to parrots than hawks and eagles. Okay, okie dokie. Okay. Difference between convergent and divergent evolution. Divergent evolution is opposite of convergent evolution. Divergent evolution occurs when two species share a common ancestor and evolve one or more characteristic and make them different to each other. Okay, this might happen because they find themselves in different environments, facing different conditions that influence their evolution. Good example is the modern elephant and the extinct woolly mammoth. These creatures evolved from a common ancestor but experience different environment. Exposed to a cold climate, mammoth adapt by growing warm and furry coats. Okay, got it. The divergent, pass. Okay. Divergent and convergent, I pass. Okay, I already get that one. But the parallel one, no. Oh my god, my brain melted. I see parallel evolution is two unrelated species happen to evolve similar traits. It's based on that environment pressure. But that is literally convergent evolution though. What you describe is what I understand of convergent evolution. Because convergent evolution is two unrelated species. Yeah. Oh wait. There were a lot of things that we thought were closely related. Wait. Convergent evolution, how does it happen? Species face different challenges cause selection pressure. Depending on their environment, these pressure could include the predator they encounter, which would be available and conditioned such as extreme heat or cold. Since DNA is the building block of life, convergent evolution starts at the level of DNA. Mutation in an individual DNA can result in a trait that makes them better suited to their environment. These individuals tend to survive more often than those without beneficial trait and pass its traits to their offspring. Over time, all individual species evolve to have a trait or characteristic that help the species to become more successful in its habitat. It's natural selection at work. Some example of convergent evolution: species evolve the same solution to a problem, but take a different genetic route to get there. In other cases, the convergence takes place at the molecular level, and the same genetic gene occurs in different species. Huh. How the fuck does it differ from parallel evolution then? What? What's the difference between convergent evolution and parallel evolution? God damn it. Oh my god. I already get the divergent one, but what's the difference between parallel and convergent evolution? What? Holy shit, this is more difficult than I thought. Because this example of the convergent evolution is falcons and hawks and eagles look very similar. Oh wait. ちょっと待って。Eh? Well, their example for a convergent evolution was falcon, hawks, and eagle look very similar birds of prey, yet they discovered that they are actually distantly related. Falcons are more closely related to parrots than hawks and eagles. So it's species that look similar, but they are not closely related. So basically, unrelated species that happen to evolve into similar traits. Because it's based from DNA and environmental pressures. Ooh, ooh, I'm confused. Hell no, I'm confused. Oh my god. Are there traits that have evolved repeatedly? Yes, this is called recurrent evolution. Oh my god. Traits that have emerged many times, including streamlined body shapes suited to swimming and ability to fly. Particularly good example of recurrent evolution is the repeated evolution of species toward the crab-like shaped body. I'm gonna skip that one. Okay. They both have the same end result, just different mechanism, like birds' wings and insects' wing. They can fly, but the wings have different mechanism. Then which is a which? Which is a which though? What is a parallel evolution compared to what's the difference between parallel evolution and the convergent evolution? Which one is which? So I'm confused. Oh my god. Can convergent evolution happen millions of years apart? Yes. Species have evolved similar traits and attributes when separated by ocean, continents, or even by millions of years. Dolphin and extinct marine reptile called ichthyosaurs, got it, are prime examples. They evolved a very similar body shape, yet ichthyosaurs lived in our ocean hundreds or millions of years before dolphin appeared. This tells us that these animals experience similar conditions and lifestyle, even if millions of years apart. In this way, conversion between extinct species and the one that still exists today can help us learn about the ecological condition creatures were experiencing millions of years ago. This is actually important for our lesson, you know. So basically, it's the... How can I explain this properly? Yeah, so it's like sharks and dolphin. The example of convergence evolution is like swimming shape of a shark and dolphin and ichthyosaur. I am confused. You know, because like convergent evolution, even though like they are not like their species are quite unrelated, like their ancestor are totally different ancestor, but they evolve into like a similar shape style because of the environment, like the environmental pressure that makes them evolve into this kind of shape that is actually practical to live and survive in that environment, which is the ocean, you know. So this is convergent evolution. Also, camera type eyes like mammals and octopus and squid, that is also convergent evolution. Opposable thumb, primate, opossum, koala, giants, pandas, and chameleons. Opposable thumbs are very useful for gripping things. Some animals have opposable toes as well as thumbs. Koala have 6 opposable digits, 1 on each foot and on each hand. The power of flight, birds, bats, moths, and many more. Many creatures develop the ability to move through air. They may have evolved this trait to better evade predator, possibly first hopping, jumping, and gliding, then developing flight from there. Bats and birds converge on the ability to fly by flapping their wings. If you compare their wings, however, you can see that how they evolved to this is very different. Hummingbirds, hawk moths are also called because they evolved the ability to hover in a very similar way to hummingbirds. Flying squirrel and sugar glider, a species of marsupial, converge on a gliding as a way to travel from tree to tree. They each evolve big flaps of skin attached to their limbs to enable them to do this. Certain frog, lizards, snakes, fish, and squid species can also glide. Prickly spine, hedgehog, echidnas, and tenrecs. That one too. Echolocation, whales and bats. That one is also convergent evolution. Okay. Meat-eating plants like Venus flytrap and pitcher plants is also convergent evolution. Anti-freeze protection. Arctic fish and Arctic and Antarctic fish, also convergent evolution. Desert survival tactics like cacti and euports, also different. Very long neck on sauropod dinosaurs and giraffe. Sauropod dinosaurs such as brachiosaurs and Patagotitan share the same feeding adaptation but even longer than the giraffe. Huh. The difference is the developmental genes. Oh. So conversion don't have the same development genes like birds and insects. In the other hand, parallel evolution have the same development genes like sharks and dolphins. They're both mammal. Sharks is not mammal. What do you mean? Oh, shark is not mammal. Sharks is not mammal. You mean whales and dolphins? Do you mean whales and dolphins? That's more understandable because they are both mammal, but not sharks. Shark is a fish. Shark is cartilaginous fish, you know? It's not mammal. But many scientists don't give a fuck and give both conversion just to resolve the problem. Oh, okay. But I still want to know the difference, you know? Yeah, Will, sorry. Yeah, I thought so. I just like, what the fuck? Shark is a mammal? Parallel evolution. Oh my god, there are only you two. Related species independently evolve similar traits at the same time. Cause similar species live in separate area. That's the word. But it's also the same as convergent, isn't it? Similar species live in separated area, but face matching environmental pressure. That's literally the same shit. What do you mean? Different species live in similar habitat face the same challenge. It's literally the same shit. You know, convergent evolution, different species live in a similar habitat and face the same challenge. So they evolve into like a similar shape that serves the same purpose. Parallel evolution, similar species live in a separated area but face a matching environmental pressure. Which is basically the same shit. What do you mean? Example, Australian marsupial mammal looking and acting similar to placental mammals elsewhere. The fuck? Oh my god. I want to go back to my high school and say sorry to my biology teacher so much because like I totally forget all of the things that he teaches us so much. I want to go back there and I'm gonna say sorry to him like, teacher, I am so fucking sorry that I forgot every damn thing that you teach me, even though I got like the damn full score in that subject. Yeah, the development genes is the key word here. Development genes. Okay, parallel evolution definition and example, please. Definition: an evolutionary process in which two or more separated species in the same environment develop a similar adaptation or characteristic for survival. It's already different definition. What the freak? Supplement: parallel evolution refers to evolutionary process wherein two or more species in the same environment develop a similar adaptation or characteristic. Example for parallel evolution: North American cactus and African euphorbia that develop similar adaptation, which is their thick stem and sharp quills to survive hot climates. These two plant species are different plant family, but live in the same type of environment. Another example of evolution of adaptive features between those two groups of organisms, living in similar habitats such as marsupial mammals in Australia and placental mammals in another continent. What? God, I want to teleport to... Can I visit my high school tomorrow and go to biology teacher to ask about this topic? Like, seriously? I want to teleport back to my high school right now to ask my teacher about this. because like the way he explained it is so easy to understand compared to like the websites, you know. So like I'm crying. Or be a scientist and say, yeah, they're both the same. Fuck. Parallel evolution is similar to convergent evolution in a way that two unrelated species evolve similar traits. However, the parallel evolution, the two species evolve the same trait. Parallel evolution. Two species evolve the same traits while living in the same type of environment. Whereas in convergent evolution, these two species evolve the same traits in a different type of environment. Aha! Finally, man. Divergent evolution. Yeah, I'm not gonna talk about divergent evolution. I already got that one. Finally, I fucking got it. Maybe that will make your teacher confused. I know. Oh my god. Yeah, I yap too much on like the scientific stuff to the point that most of people are gone from the live stream. Okay, so basically, parallel evolution is two species evolve the same traits while living in the same type environment. But the convergent evolution is a two species evolve the same trait but in different type of environment. But that low-key doesn't explain like the shape of the shark and the dolphin, you know? Because like they literally live in the water. Like I don't know how to explain this. Oh my god. Okay, back to being confused. Oh my god. Okay. Convergent evolution, okay, so parallel evolution occur when independent species acquire similar characteristics while evolving together at the same time in the same ecospace. An example of parallel evolution is extinct browsing horses and Paleotheres. The difference between the parallel and convergent evolution is as follows. Parallel evolution occur closely related species. Parallel evolution occur in closely related species that share a recent common ancestor and therefore evolve similar traits. Convergent evolution occur in a distantly related species that do not share recent common ancestor but evolve similar traits. Nonetheless, because they face similar environmental challenges. Sometimes the ancestral forms are unspecified or unknown, but the range of traits considered is not clearly specified. In such case, distinguishing between parallel and convergent evolution is not straightforward. For example, the striking similarity between placental and marsupial form has been considered a case of convergent evolution because they each had a long evolutionary history prior to the extinction of dinosaurs under which to differentiate. However, they have also been viewed as an example of parallel evolution starting from the common ancestor of all marsupial and placental. In the end, whether a particular case is considered parallel or convergent may depend on how far the one looks into their ancestral line. Okay, thank you for the clarification. I'm not gonna fuck with that thing anymore. I'm not gonna fuck with that topic anymore. Okay, let's move on to co-evolution. Yep. Yeah, I took too long on this thing. I took too long to understand these things, man. Oh my god. Co-evolution. Where two or more species interact over a long period, the possibility of mutually beneficial adaptation or co-evolution arise. For example, flowering plants develop a flower with colored petals to attract insects, which then cross-pollinate and fertilize the plant, so that the plants produce seeds. The form of different flower species also have co-evolved to accommodate specific insects and, less frequently, birds. In addition, the evolution of various attractive nutrition, fleshy berries and fruit have led different birds and fruit-eating mammals to develop feeding habits that utilize such resources. The benefit to the plant is that its seeds pass through the gut of the consumer unharmed and are distributed in droppings of neutral fertilizer. Okay, I get this one too. So we can call ancestor development toolkits. I would say that one. Yeah, oat. Yeah, that is the correct word. Okay, co-evolution. Two species evolve together due to their close relationship. When one evolved, the other ones evolved too. Got it. Example, birds and bees and flower for pollination, predators and prey. Got it. Understandable. Easy. Divergent evolution. Yeah, Galapagos Island with the birds. Got it. Convergent evolution. Species with different ancestors becoming more similar. Same environment. For example, a dolphin and fish have very different ancestors. Okay, but both have evolved flippers because they live in the sea. Okay. Yeah, we should only talk about divergent, convergent, and co-evolution. Yeah, that's it. We should talk about that. Phylogenetic tree. Okay. Shows evolutionary relationship among organisms. As you go down the tree, you can go back in the time to a common ancestor. Okay, branching out means natural selection caused speciation. Got that one? Okay. How do I read phylogenetic tree? Here is the one that is important. Phylogenetic tree. Let me take a note of that so I can read more on that later. So I don't forget to research on that shit. Genetic tree. Okay. The closer two lines are to each other, the more closely related the species. Okay. The further away, the more distantly related. Okay. Got it. Can I read more PowerPoint, please? Or you just have 11 slides? Really? Only 11 slides? Damn. Anyway, thank you for the clarification. So much. Yeah. Okay. Got that one though, nonetheless. Okay, let's go back to like also carry hereditary information from genes. Nope. Let's drive evolution. Yes, this one. Let's drive evolution. Yes. We need to cover this topic. Evolution is fueled mainly by the process of selection and competition. This acts upon species which respond by having offspring that contain inherited Variation. Most species tend to produce more offspring than can survive. Natural selection favor. Keyword natural selection. Okay. Keyword natural selection. Natural selection, of course. Survival of the fittest. Yeah. Got it. KKK. Got that one. Ito. Okay, survival of the fittest. Those best adapt to physical and biological environment, such as the particular climate or escaping a predator. These survivors select other similarity adapt to the mates to produce offspring that can survive a greater number and to breed new generations. Got it. Adaptability. Without adaptability, life would never have moved out of the ocean. However, even adaptability is largely a result of cause and effect. Life cannot predict the future needs. Instead, new traits are produced in individuals by genetic variation and mutation when random changes in genetic codes are introduced, for example, by errors in copying. If these are favorable, natural selection promotes their transmission to future generations. For instance, flight in how do I say this again? Pterosaur and bat, based on the membrane stretch between or form fingers, may have originated as an adaptation to glide away from predator, which themselves later became adapted to a power flight. Pterosaur. Yeah, that looks the same. Okay. Yeah, so keyword natural selection, and then there's adaptation. Okay. Speciation and extinction. Fossil records show that throughout Earth history, species have evolved and died out. Species is a population of organisms that can interbreed, producing fertile offspring and sharing their genes in the process. Most species that have evolved are now extinct, but their genes survive in the living descendants. Speciation is the process by which new species evolve from an ancestral species. And it can be brought about in a number of ways. For example, environmental change can fragment population, leading to the geographical genetic isolation of different groups. Over time, genetic variation and adaptation to new circumstances alter the gene pool of these groups, to such an extent that even if they did come together again, members of different groups would not be able to breed or produce fertile young as they would have evolved into separated species. Also, various regional and global environmental catastrophes have impacted upon life and resulted in mass extinction. The largest of these at the end of Permian times caused 96% of all species on Earth to die out, yet life recovered. Got it. Ito, reverse. Oh my god, my voice. Reversal in evolution. Animals as diverse as whales, snakes, ostriches are all essentially theropods, four-limbed creatures descended from a land-living ancestor that used its limb for walking. Over time, they have all adapted to very different lifestyles and habitat, with a radical modification of their appendages and bodies. The whale forelimbs have become paddle for swimming and steering, while the hind limb has been lost altogether, although vestige of the pelvic girdle remain. By losing all four limbs, snakes have adapted into a different mode of movement, throwing the body into S-shaped curve and using the friction of scale to move forward. Finally, the flightless ostrich is descended from a flying bird, which has four limbs modified into wings. Such loss of original limb is termed a reversal evolution. Although evolution is a process of constant adaptation rather than steady progress. Okay. Got that one. Macroevolution and microevolution. Genetic change that lead to creation of a new species are known as microevolution. Changes in higher level of taxonomic groups such as families and their pattern of evolution are referred to as macroevolution. For instance, a small-scale changes separating house sparrows population or the herring gull from the lesser black-backed gull, which share a common ancestor, are microevolutionary. The changes that occur between mammals such as sea lions and their remote egg-laying ancestor, however, are macroevolutionary. Sea lions are aquatic animals, but they give birth to live young on land and suckle them with milk. The platypus is monotreme, the most ancient order of mammals. It had duck-like bills and lay eggs, yet also suckle its young with milk. Okay. Evolution through geological time. Here we go. Over 99.99% of all species that ever lived are extinct because life have evolved for over 3.5 billion years, and species rarely survive beyond a few tens of millions of years. For 3 billion years, life meant microscopic marine organism is only moved into fresh water and onto land 470 million years ago. And not until 300 million years ago were plants able to colonize dry upland. Okay. So there's no life form on land at all before that. Huh, interesting. Even the plants. The whole group of organisms have evolved and become extinct. Fossils reveal a pattern of rapid bursts of evolution, dispersal, and extinction, sometimes with waves of evolving population, replacing one another as well as gradual background evolutionary change. Evolutionary innovation have allowed new niches, the environment or ecosystem that an organism inhabits and interact with, to be exploited, and extinction has empty niches and around newly evolving groups to diversify into them. Additionally, climate change, changing sea level. Here we go. Climate change, changing sea level, extensive volcanism, and plate movement all affected evolution. Here we go. That one, I should take a note on that. Be from glaciation, mind you. Extensive volcanism. And plate movement, plate tectonic movement. My goodness. Let's see next. Yosh. Okay, next page. Classification. Okay, this one probably important too. Where the hell can I move into Paleozoic era? Oh my god. Yeah, but I need to take an understanding of like the basic of like the evolution and biology first, I think, to understand these things. Not gonna lie. Because I really want to cover all these แบบคืออยากจะรวมไอ้พวกเกี่ยวกับเรื่องแบบ basic knowledge แบบความรู้พื้นฐานในเรื่องของการวิวัฒนาการด้วยอ่ะคืออยากจะรวมเรื่องพื้นฐานอย่างเรื่องการวิวัฒนาการแล้วก็การสูญพันธุ์แบบครั้งใหญ่อะไรอย่างเงี้ยก่อนที่เราจะไปเริ่มcover ในส่วนของแบบยุคสมัย Paleozoic era จริงจังอะ you know โอเคขอลองอ่านก่อน Classification with many millions of species estimated to be alive today and many in danger of extinction. Okay, blah 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 blah. Okay. Linnean and phylogenetic classification. Scientific classification of life was found by the 18th century Swedish botanist Carl Linnaeus, who attempted to group like wish-like based on species in a hierarchy designed to illustrate a God-given order, adopted by evolutionary biologists. It attempted to reflect the natural groups and evolutionary relationship, thus feather birds in the class Alpha. Placed at the same level or rank as the class Repta, but fossils have shown that birds evolved from reptilian dinosaur. Their class nests within the class of reptile. Phylogenetic classification tried to remove such contradiction by distinguishing a series of descendant groups with common ancestry is based on the unique shape characteristic. Okay, key extinct fish, living fish, gastenomata. Okay. Okay, this one is extinct. Okay. That one evolved. Hagfish, yeah, from ancient days is still alive. This one evolved into that, and oh shit, okay. 520 years ago, okay. Arandaspes, okay, is at 480 years ago ish. Huh. Okay. Linnean hierarchy. Linnean hierarchy begins with biological species identified by the Latin species and genus names. There can be one or more closely related species in genus. Genera are grouped in ascending order into families, order, classes, phyla, kingdoms, and domains, with the aims of reflecting a meaningful relatedness in evolutionary terms. Okay, there's domain, Eukarya, highest currently recognized taxonomic division of life, with 3 domains: Archaea, Bacteria, and Eukarya. Eukarya are distinguished by membrane-bound cell nucleus. And then there's kingdom, which is Animalia. Today there are at least 28 kingdoms, whereas there used to be just 2, Animalia and Plantae. Animals are mainly multi-cell eukaryotes. That consume other organisms as primary food source. Okay. What else? There are prerequisites for evolution knowledge. It is a living thing, or you can read the topic called life science first. Oh yeah, true. I think evolution is middle of that life science topic. I think that's why you have so many questions or cause some confusion. Yeah, I think so, to be honest. Yeah. When I dig I feel like when I dig deeper down, I realize that I only know about biology like only on the surface level of like biology. Like seriously, I only know like surface level of biology. Like there's still a lot of things that I need to learn. It's more complex than I understand. You know. Okay, okay, this one I understand, you know, domain, kingdom, phylum, class, order, family, genus, and species. Got that one. Okay, already know that one. Let's see. Classification of life, bacteria, okay. Domain, bacteria, kingdoms, 10, species, several millions. Archaea, domain Archaea, kingdoms 3. Okay, eukaryotes, domain Eukarya. Kingdom at least 15, species 2 millions. Okay. So eukaryotes. Let's see, eukaryotes, they have protists. Single cell protists are diverse group of microorganisms that were viewed traditionally as a major group. However, details of their biology show that they have very little common. Some are plant-like, other animal-like, and yet other are more like fungal slime molds, indicating that they have evolved from separate origins. Shit! So eukaryote, they have like protists, red seaweed, plant, brown seaweeds, and fungi. Oh, I just realized about that. So then there's animal, where there's invertebrate, chordates, tunicates, lanceolates, and vertebrate. Huh. Oh wait, chordates are more like a fish, right? Item. Oh wait. Oh, now I understand. Holy shit. I never know about this terminology before. I thought like I never know that there are more like classification. I only thought like there's only like vertebrate and invertebrate, but I never know about like chordates and tunicates and lanceolate, man. Holy shit. Also about the eukaryote too. I thought it's only like plants and fungi. And protists, you know? Holy shit. This is interesting. This is so interesting. I can read for ages. Oh my god. Don't worry, the real biologists also know only their knowledge area. Yeah, I know. But yeah, I wanna learn more about these too, though, nonetheless. Wow. Okay, I should read these later. Okay, let's go. Mass extinction, yes. Well, let's see that one later. Type of fossils. Here we go. Fossil remains are preserved by diversity geological process. Yeah, I want to talk a little bit about like fossil stuff too, you know, before we head into the Paleozoic era. You know, just to as a foundation knowledge before that. So I'm not gonna a little bit of like fossil evidence, you know, just like a surface level of knowledge a little bit for you guys during the Under the Sea. That would be good. fossil is the remains of one living organism that has been preserved in a rock. Okay, fossils were once thought to be the remains of both animate and inanimate things, but by the end of the 17th century, it was generally agreed that they were purely organic origin. Although the fossilization process has usually resulted in considerable chemical change. There are these fossil types: body, trace, and chemical fossil. Okay. Trace and chemical fossil. Body fossils include fossilized remains of hard parts such as shell, bones, teeth, and some plant material, while trace fossils are marked, preserved in a hardened sediment that record evidence of past life, such as footprints. Chemical fossils consist of degraded organic substance from a molecule of living things, such as fossil DNA recovered from bones or teeth. No matter how they are formed, many fossils can be identified at species level. Hell yeah. Well preserved in this Jurassic ichthyosaur, okay, again, ichthyosaur, which is called Stenopterygius, Megacephalus, is a true fossil. It might look almost perfectly preserved, but what appears to be a skin has been replaced by microbial film. Ooh, interesting. Okay. Body fossil and trace fossil. Okay, I understand that. How fossil form? Organic remains are fossilized in many ways. There is almost way to lost information as the remains decay and are buried, compressed, and sometimes heated. At the best, soft tissue such as feather can be fossilized, but at worst, all that left is a trace, such as footprint. The chances of any remains being fossilized are actually very slim, especially if organisms have no easily preservable hard parts, like shells or bones. Organic remains are commonly preserved in places where they will have little or no disturbance, such as in still or slow-moving water. Even delicate tissues can be preserved when decay is slow or even halted by low oxygen level, low temperature, or unnatural preservatives such as tar or resin. Okay, this is important. Okay, this is important part. Yeah. Now fossils are formed. Okie dokie. Wind and rain can expose fossils by removing the surrounding softer rock. Petrified chunk of Triassic conifer. Unaltered preservation. Very occasionally, the unaltered remains of organisms are completely preserved, particularly in cases when the hard parts are made of minerals that do not degrade or recrystallize over time. For example, shells and skeleton are made of calcite, found in echinoderms such as starfish, are more stable than those composed in aragonite, which is found in mollusks. Silica is another stable material that is found in some sponges and microscopic algae known as diatoms. The organic materials is essentially unstable, so shall lose not only soft tissue but also their color, except under special circumstances such as when they are covered with resin. Even then, however, microbes can still be degrade degrade a fossil, although it may look perfect on the outside. Okay. Got it. Recrystallization. Crystallize. Oh shit, this creature looks like a dick. I'm sorry. I'm sorry, but like, holy shit, that looks like a dick. It's even got ball. What the frick is that? Neuropterus Scuseri leaf. But it looks like a dick. It's a leaf, but like the fossil decarbonization is the example of decarbonization, but like that looks like a dick. I don't know how can... Wait, let me search a picture on the internet. It should appear on the internet, right? It's new Ropteris Scuseri leaf or Scuseri leaf. Fucking hard to pronounce. Where is it? On the internet, it's just like a block, like just a leaf itself, but like on the book, it's freaking have balls. Yeah, this one is similar. Okay. Like it literally have balls. Like the version in the books is literally have balls. Yeah, there's no same picture in it, but there are some picture that is similar, nonetheless. No, like Loki is look like a. It's literally look like a T. But it's a leaf, you know, it's a leaf fossil. It's a carbon, like carbonization, which is a complex organic compound that make up of plant tissues, are prone to a chemical change called carbonization, which result in a loss of their watery component, yet leaves a carbon residue that is much more stable over time. When plant is covered by a sediment, burial compresses and may even heat its remain. Pressure squeezes out any liquids and gas and flatten the plant's tissue. Heat may turn these into charcoal, leaving only carbon behind in the form of compression fossil. Over time, even this carbon residue may be lost, leaving it in its place only an impression and outline of the plant tissue. In fine-grained sediment, this is often enough to preserve a detailed information so that the species can be identified. And this process is particularly effective in preserving leaf and delicate animal form. Though he does look like a dick. Can't wait for pre-roll pictures. Oh my god, this one on the internet is even worse, man. Oh my god, this one. Am I gonna get banned? Like, the one in the books is still like acceptable, but like the one that I find on the internet is even worse, man. Like this one is even worse. Which one can I show on? Which one can I show on the live stream? Actually, I'm just gonna take a photo of it and post it in like the Discord server. Not gonna lie. Yeah, I'm just gonna put it in Discord server. Cause this is too yabai, okay? This is too yabai, and I'm gonna put it in like not safe for work one. I'm gonna put the in the not safe for work room because like I'm not sure. Holy shit. Okay, where is it? Yeah, I'm gonna put it in the not safe for gathering. In question. Yeah, just check the not safe for work gathering in the Discord server. Yeah. Like the one on internet is even worse. I don't know if I can even like put it on, you know. So let's go. The bachelorette is looking at DP on a Sunday day while live streaming. Fossilization DP. It's not really like a D, you know. It's a leaf. Like it's a fossilization, like carbonization remains of a prehistoric leaf, you know. But it just looks like a D. Yeah, just check the Discord server if we need. ยังไม่แย่ขนาดนั้นมั้งมีถ้ามีว่าอันนี้ไม่แย่เดี๋ยวหนูส่งอันนี้ให้มีถ้าอันนี้ไม่แย่เดี๋ยวหนูส่งอันที่หนูเจอในเน็ตให้หนูส่งอันที่เจอในเน็ตให้เพราะอันนี้แย่กว่าอีกเดี๋ยวนึงนี่เดี๋ยวแป๊บนึงนะรอโหลดแป๊บนี่คืออันที่หนูเจอในเน็ตแย่กว่าอีกอะพี่แย่มาก What is it called? Yes, Gursery, a hairy trifoliate canoe. It's also hairy. โอเคนะมีเก็ตนะเข้าใจนะว่าทำไมหนูโชว์ให้บนไลฟ์ไม่ได้ ถึงแม้ว่ามันจะเป็นฟอสซิลใบไม้โบราณก็เหอะแต่ว่า มันอย่าใบ้อะมันอย่าใบ้มากเลยอะ I think it's safe for live, but yeah. Okay, let me read some of these. Recrystallization, okay, you know, it's covered in crystal, basic. Replacement, the complete replacement of an organism structure with another material is common during the long, complex process of fossilization or petrification, okay. Burial of fossil remains and transformation of the surrounding sediment into rocks evolve physical and chemical changes, the latter often resulting from the groundwater that saturate the sediment. Groundwater containing dissolved chemical commonly substitute them, atom by atom, for original fossil minerals so that fine details are often preserved. Silica often replaces and fills in cell spaces of woody fossil plant stems, while the iron sulfide mineral pyrite replaces the aragonite of shells of mollusks such as ammonite. Got it. Impression molds and casts. How does it differ from carbonization though? When an organism is pressed into soft sediment, it creates a negative impression, and many its external details are recorded in negative relief, because this compression effectively forms an external mold of the fossil. Any sediment that latter fill that later fill it in or fill in the space within the fossil itself, such as the hollow inside a seashell or skull. Form an internal mold which detail preserved in positive relief. If fossil material degraded and disappear altogether after the surrounding sediments harden, this mold still preserve and record the fossil internal and external structure. Scientists often use natural mold to make artificial casts of such missing fossil in order to study their structure in greater detail. Okay, got it. Okay. Okie doke. Oh, this one picture is pretty cool. The picture in this book is pretty cool, man. Okay, the making of fossil as well as supporting living organisms, bodies of sea and water and freshwater can also preserve their remains. Buried within the sediment at the bottom. Much depends on the condition at the boundary between the sediments and the water. But wherever fine-grained muddy sediments are deposited, preservation can be remarkably good. For example, the detail of covering of top bony scale on the body and fins of the type of marine fish called a coelacanth may be preserved more or less intact along with the bones of the head if the carcass come to rest in water without enough oxygen to support the scavenger. The different stages in the fossilization process are shown here. However, in well-oxygenated water, scavenger may consume the body altogether, leaving just some bones and scale preserved in the fossilized feces. Okay, so there's dead full form burial. Okay, where and how quickly the organic remains are buried makes a great difference to their preservation. As a fossil, if the coelacanth settle in the fine-grained mud of a quiet lagoon, most of its scale-clad body may be preserved. However, more typically, the body will be disturbed by water action, and it will be broken apart and worn down before it's finally buried. The illustration right shows a cross-section of a sediment-covered scale. Okay, yeah, this one is visual explanatory. And then the decay, and then replacement, and then rock formation. Okay, got it. Got that one. Living coelacanth and fossilized coelacanth. Okay. Got it. Information in the fossil record. Oh, this one is also important. Fossil reveal extraordinary and wonderful detail about ancient life. They tell us about living organisms look like and how they behave in the environment they live in. They can also be used to estimate the ages of the rocks in which they are found. Life in the past. While only a small portion of life on Earth has been preserved in the fossil record, fossils still provide most of the data we have about prehistoric life and its development within the planet's changing environment. The fossil record favor creatures with hard preservable parts, yet it had revealed the outlines of histories and evolution of major groups of organisms, including extinct ones such as trilobite, ammonite, dinosaur, seed, ferns, and our own earliest ancestor. We now have records of evolution over at least the last 600 million years, showing how life developed in seas, emerged to land, and how ecological relationships were established between first plants and animals. Despite catastrophic extinction events, life has evolved and adapted to fill Earth available and habitable niches, from ocean depths to mountain tops. Okay, fish eating fish fossil. Oh shit. Oh shit, that fossil is so cool. What? That fossil literally preserved the moment that like a large fish eating another fish meant like that is actually so cool. Like what? It's like the fossil literally preserved the moment of like it's eating the other species of fish. Holy shit. This predatory fish, Myoplosus labracoids from the Green River Formation in Wyoming bit off more than it could chew when it tried to swallow its prey 50 million years ago. The scarcity of other Myopolus fossils indicates that this species was solitary predator. Huh. That's so cool, man. That is actually very cool. Fossil footprint. Much can be learned about ancient animals' behaviors by studying the preserved marks they left on the ground, such as dinosaur footprint found in Middle Jurassic age strata as Artley in can't pronounce the city name in England. It's Oxfordshire. Oxfordshire. Something like that. They form tracks way up to 180 meters long. Triassic fossils like these keep scientists calculate how fast extinct animals such as dinosaurs walk. Oh shit, there's like angle calculation. So there's like walking and running footprints, stride lengths. There's some like angles. That's cool. Shit! It's time for me to take the birth control pill. Sorry. Yeah, I might need to end the stream right now, y'all. Yeah, I think I studied for too long. It's time for me to rest. Yeah. I think it's time for me to rest for now, guys. I still need to study more about this before the next installment of Nerd Under the Sea for real. Yeah, so I'm gonna post the live stream schedule for next week, which is like tomorrow stuff. Tomorrow morning. Yeah. Hopefully I can post the stream schedule tomorrow morning if I do not forget. So yeah. Thara studied so hard. Thank you. Good night, Ocean Faye. Thank you. So I think tomorrow I won't be streaming tomorrow because I want to rest a little bit considering my health is not that good right now. Like my health condition is not that good right now. I still have weak stomach because of the ไวรัสลงกระเพาะพูดง่ายๆทาราไวรัสลงกระเพาะมาประมาณสัปดาห์นึงแล้วนะคะแล้วก็ไม่ยอมกินยาฆ่าเชื้อแล้วก็ไม่ยอมไปหาหมอนะคะเพิ่งไปหาหมอมาก็เลยโดนหมอยัดยามาเยอะมากเลยตอนนี้ก็เลยวีคสุดๆนะคะก็เลยเดี๋ยวพรุ่งนี้ขออนุญาตไม่ไลฟ์นะคะเดี๋ยวมาเจอกันอีกทีวันพุธเลยละกันนะคะผมขออนุญาตไปพักผ่อนก่อนเนาะแล้วก็เดี๋ยวโพสต์ตารางไลฟ์ประมาณวันพรุ่งนี้เช้านะคะผมI don't see any adults study fundamental science or biology so often. Yeah, I just so fascinated about this. I am so fascinated about this because to be honest, the reason why I only studying this now is because I did not get a chance to study when I was a student,คือเพิ่งมารู้ตัวว่าแบบตัวเองชอบ marine biology จริงๆอ่ะก็ตอนแบบปี 3มาแกเข้าใจปะคือฉันเพิ่งมารู้แพชชั่นของฉันตอนฉันขึ้นปี 3มาแกก็เลยแบบนะมันค่อนข้างสายไปแล้วอ่ะก็เลยเพิ่งมาเรียนรู้ตอนนี้นะครับผมทุกคนนั่นแหละ Yeah, it's too late because I already into year 3 of university when I realized that I really passionate about marine biology study, So it's quite literally too late in my life to change the faculties and things like that. Considering I did not study math and science at all during high school too. During high school, I was in arts and Chinese section. So I am art and language kids through and through. In terms of my education level, I am arts and language kid through and through. So yeah, when I realized that I really passionate about marine biology, it was kind of too late for me to like even apply in the faculty of science, because like I don't even have the basic knowledge to like apply in that faculty, so yeah, I'm gonna do what I can as a person who finally graduated from university and still have time, because I'm still jobless. I am still jobless, so that's why I still have time to studying these information, which I did not have a chance when I was in school. So yeah, that's why I'm very passionate about this. Yeah. Oh my god, yeah. Dismiss. Yeah, that's my alarm for the time to กินยาคุม Yeah. So yeah. แล้วโอเคเรียนตอนไหนก็ได้ไม่มีช้าไปหรอกค่ะนั่นแหละก็เลยแบบว่าเพิ่งมาเรียนตอนนี้เนอะก็แบบสนุกมันสนุกแกคือเข้าใจป่ะพอจะเข้าสู่วัยทำงานแล้วมันก็จะไม่มีโอกาสไปเรียนอันเนี้ยแล้วคือตอนแรกก็คิดหรอกนะว่าอยากไปต่อโทสายวิทยาศาสตร์เหมือนกันแต่ว่าฉันไม่รู้ไงว่าสกิลความโง่อย่างฉันจะไปเข้าคณะนั้นจะสอบเข้าคณะนั้นได้หรือเปล่ายังไม่รู้เลยก็เลยแบบเรียนรู้จากอะไรตรงนี้ละกันวะอะไรอย่างเงี้ยLifelong learning is great. I do it every day. That's why I developed my own research tool to answer my bothering question. That's pretty good though. That's pretty good. But yeah, I'm gonna learn about these stuff later, and I'm gonna post the live stream schedule like hopefully tomorrow. But I think tomorrow I will take a break, and then we will see each other again on Wednesday with Hades 2 stream. Yes. But this time, yeah. You know what? This time, I did have a new idea for Hades 2 stream. Considering our only goal right now is to 100% the game for Hades 2. So, I did have a little bit of idea while we're gonna play Hades 2. I'm gonna yap about Greek mythology while playing Hades 2. Yeah. So it's gonna be another educational stream while me gaming Hades 2. That should be good, right? That should be good. That should be interesting, right? Because like a lot of the Greek mythology in that game, I still did not cover that much. I only covered the Greek mythology aspect in the first game, but like not in the second game that much. So it will be interesting while I play Hades 2 and then I yap about Greek mythology stuff while I'm playing Hades 2. So yeah, that will be my plan for Wednesday. But yeah, that's it for today. That's it for today. Thank you guys so much for watching. If you guys enjoy, please feel free to hit that like button, subscribe to my channel if you guys haven't do yet, and don't forget to turn on the notification bell so you don't miss any kind of update on this channel. Also follow my social media, and if you guys want to join our community of Jelly Salad, that is my fan club name. Feel free to join our Jelly Salad Discord community. The link is already in the description box down below. And also for all Thai folks, the merchandise relaunch is still on sale, so be sure to order that on Friendly. The link is already in the pinned comment in the chat box and also under the description down below. ก็สำหรับคนไทยนะครับผมตอนนี้ยังเปิดขาย merchandise relaunch อยู่นะครับผมลิงก์อยู่ในเว็บไซต์ Friendly เลยนะครับผมสามารถไปสั่งซื้อได้เนอะเป็นสินค้าที่ผลิตไว้อยู่แล้วนะครับแล้วผมแล้วก็มีจำนวนจำกัดแล้วก็คือเป็นอารมณ์จะเรียกว่าเป็น clearance sale ก็ว่าได้นะฮะก็สามารถไปจับจองสั่งซื้อกันได้หมดแล้วหมดเลยไม่มีผลิตเพิ่มนะครับผมก็ฝากไว้ด้วยนะครับผมแล้วโอเค and then I will see you guys again probably on Wednesday at 8 p.m. UTC plus 7 that will be 6 a.m. PST and 9 a.m. EST on Hades 2 stream while me yap about Greek mythology. So yeah, that's pretty much it. Wherever you guys are in the world right now, I hope you guys either have a great day or a good night. For me, it's a nighttime, so it's a good night. And I will see you guys again on the next stream. Good night, guys. Bye-bye. Good night guys สวัสดีค่ะผมขอบคุณที่มานะบ๊ายบาย